This is going to be a video lesson for section 2.4, which is multiplying rational numbers. Rational numbers includes both fractions and decimals. We're going to take a look at both types of multiplication. Now let's jump right in and let's start with fractions. Let's say you're multiplying something like 3 over 5 times 1 over 3. Small fractions, pretty easy. In addition, you would have to find a common denominator. In multiplication, that's not the case. You don't need a common denominator to multiply two fractions. You simply multiply across like this, and you're done. Now, since it's so easy, we're going to do one more thing to these fractions before we're done with them. Simplify them. And you can simplify after you multiply. You can simplify first and then multiply. I use the strategy of simplifying first and then multiplying because usually it makes my multiplication a lot easier. So what I'm going to do, I'm going to put them together. So I'm going to have 3 times 1 over 5 times 3. And I can do that. It's multiplication. So just like with variables, I can put two things next to each other. As long as I put the parenthesis, it implies multiplication. Now the next thing I want to do for simplification is look for similar factors in the numerator, the top, and identical factors in the denominator, the bottom. So I'm looking for anything that's the same essentially. 1, not really. 5, nope. 3, 3. I found a pair of 3's. And when I do that, when I find two factors that are the same in the numerator and the denominator, I can cross them out like this. So cancel them out. And the result is a 1. Well, why 1? Because what's 3 over 3? Well, it's a 1. So what's left here is essentially a 1, and multiplying by a 1 or dividing by a 1 is the number itself. So it's gone. So what's left instead is on the top of 1, on the bottom of 5. And that is our answer to this particular problem. Let's take a look at a slightly more involved example. Let's say we have 6 over 15 times 25 over 8. And yes, I know this is an improper fraction, so let's just go with it. Once again, your order of business here, because this is a multiplication and you do not need to find a common denominator, is to simply multiply across. Numerators times numerators, denominators times denominators. But before you do this, I highly suggest you simplify. And this is how I do it. First, I'm going to write them next to each other. Then I'm going to look for things that I can cross out that are the same on the top and the bottom. 6, no 6, 25, no 25, 15, no 15, 8, no 8. Looks like there's nothing there to cross out. But I can break each one of these down into their component factors, like this. 6 I can write as 2 times 3, because 2 times 3 is 6. 25 I can write down as 5 times 5, because 5 times 5 is 25. 15 I can write down as 3 times 5. 8 I can write down as 2 times 4. I can break this 4 down into 2 times 2 as well, but I'm going to leave it now because I know I'm not going to need it. But it would be a good idea later on to do that as well. And now I'm going to look at anything that I can cross out. That same number on the top that is on the bottom. So the two factors that are identical in the numerator and the denominator. I have a 2 here. Do I have a 2 on the bottom? I do. I have a 3 on top. Do I have a 3 on the bottom? I do. I have a 5 here. Do I have a 5 on the bottom? Do I have another 5? Nope. Do I have a 4? Nope. So what's left is a 5 in the numerator and a 4 in the denominator. That's it. Very simple. Technically, I didn't even multiply anything because there was nothing left after the simplification for me to multiply. You could also run into a number or a problem like this where you have a mixed number, 2 and let's say 1/2 plus 3 and a third. Just like in the addition problems, the first thing to do here, sorry, not add, but multiply. Too used to adding. Just like in the addition problems, though, your first order of business is to convert the mixed numbers into improper fractions. 2 times 2 is 4, 4 plus 1 is 5. 3 times 3 is 6, 6 plus 1 is 7. And then you go ahead and cross multiply. I'm going to put them right next to each other. And then I'll look for things to simplify. I have a 5, 7, 2, 3. Nothing looks alike. Can't break down the 5 into anything. It's 1 times 5. Same thing with a 7. Same thing with the 3. Same thing with the 2. Unlike the case before, where I could break down the 6, 25, 15, and 8 into their component parts, nothing to break down here. That can happen too. There's nothing to simplify. So then you simply multiply 5 times 7, 2 times 3. And of course, if you wanted to, you could write this down in its proper form as well. You don't have to. I'm perfectly fine with improper fractions. So that would be, either one of these would be your answer. There was simply no simplification for us to do in this particular problem. The last case where you might see in 2.4 is, well, actually, before we jump to that, let's do this. You might be asked to multiply a fraction, say 11 over 12, by an integer, not a fraction, purely an integer. Let's say times 14. Well, normally you're used to multiplying fractions which have distinct tops and bottoms, numerators and denominators. Here you have a fraction with a distinct top and bottom, and then you have that. No top, no bottom, just a number. You can write any number. You can write any number whatsoever over 1, and it's still the same number, because if I write 14 over 1, what's 14 divided by 1? 14. I can write 5 over 1, it's still 5. I can write 6 over 1, it's still 6. So, in these cases, what you want to do is write your integer over 1, because 14 over 1 is still 14. But now it gives you that distinctive top that you can use. So just like before, you would multiply across. And just like before, I'm going to combine them. And then I'm going to look for things that I can eliminate. Well, really I can't eliminate much from the 11 because there's nothing that's an 11 down here, and 11 is a prime number. The 1, can't do much there. But the 14 and the 12, I can write them as such. The 14 can be 2 times 7. The 12 can be 2 times 6. Now, 2, 2. I eliminated that 2. So what's left in the top? An 11 times a 7. Down here we have 6 and a 1, 6 times 1. 11 times 7 is going to give us a 77. 6 times 1 is 6. And that's technically it. You can of course convert that into a proper fraction, a mixed number, but we don't have to do that here. It's perfectly fine. So I'm going to do a part 2 where we're going to talk about multiplying decimals. So look for that next to this video.